How about the equations?
So, let's see, this is a dry erase marker. So our equations, I'm going to show you something here. So the equations are called constant acceleration kinematic equations. So that means that acceleration has to be some constant. So let's say that A is just equal to itself, A. The equation for A in terms of t, let's do that. So A in terms of t is a constant. And you don't need to, oh yeah, you can write this in your notes, but say we integrate this. So integration, have you done any integration yet?
Mm-hmm.
Okay. So integration is like the opposite of a derivative. So you remember how we had x squared, 2x, and 2?
Mm-hmm.
Well, it just goes backwards. So the integral of 2, you increase the power by 1, and you divide by the new power. So you increase it to 1, you divide by 1. So the integral of 2 becomes 2x.
Okay.
If you want to integrate for 2x, then you increase the power to squared, and you divide by the new power.
Okay.
So those cancel. But the problem is, you can watch and see what happens if you try to take an integral. Say you have x squared plus 3x plus 2. What would the derivative of that be?
Let's see, 2x plus 3 plus 0.
Yeah. Then what's the derivative of that?
Let's see, be 2 plus 0.
Yeah, 2 plus 0. So this is the limitation of the integral, is that we don't know the initial condition. So when you integrate this, remember how we said we'd get 2x?
Uh-huh.
Well, obviously 2x isn't equal to that,
Uh-huh.
but 2x plus some constant would be. So when you integrate, you actually, every time you have to have a plus c to kind of say, I don't know exactly where I started, but this is how much I'd change. And then you do the same thing, so you could, when you integrate this. Okay, so that's just basic integration. You don't need to have that totally under your command yet, but say we were to integrate this, just treat a as a constant, say, it'd be like a is equal to 2. If you integrate that, you increase the power by 1, so you have, and t is your variable rather than x. So you increase the power by 1 to a t, you divide by 1, so you just divide by 1, plus some constant. So this tells you how much your velocity changes, but this tells you where you started.
Okay.
So this would actually be your initial velocity, right?
Mm-hmm.
So you can say v final equals v initial plus a t. You recognize that?
Yeah.
That's one of your kinematic equations. Now let's take it one step further. If you say, okay, x of t, what do we do to this one to integrate it?
Add a z.
We'll replace this with v initial. So you increase the power of the t by 1.
Okay.
So
So
it'll be a t squared. But then you have to divide by 2.
okay.
And then vi, you do the same thing that happened here. So you have vi times t
Okay.
plus c. Well, it turns out your c, again, is your x initial. You have x final equals x initial plus v initial times time plus 1/2 a t squared.
Oh. All right.
It's probably easier for you to see it going the opposite way. If you take the derivative of this, that gives you velocity. This will go away. This will become vi, and this will become, you bring the power down, so 2 times 1/2, it's just 1. To the 1 less power is at. So that's that.
Okay.
So that's where those two equations came from. And those I'd definitely write down as far as kinematic equations, because you use those a bunch. But that's where they came from. I mean, hopefully that gives you a better understanding of like what they are, because you can see that it's just an integrate.
Yeah.
It's just integration.
So what's X's position? X final?
Yeah, so this is saying that the X at whatever T,
Okay.
so that'd be equal to X final, basically. So this is the way they write them, but it's just an integral, it's just integration up from A.
Okay.
Now the last equation, do you remember what it is?
Mm-mm.
It's got some squareds in it. So this one is V final squared equals V initial squared plus 2A delta X, or delta S, whatever you want to call it. This one is just using these two together, kind of combining them to get rid of T.
Okay.
And so all it is you actually take this and you solve for T. So it becomes V final minus V initial all over A equals T. And then you plug this into this equation anywhere there's a T. And then you just simplify it.
All right.
We won't go through all of that, but that's where the 3 came from. So I definitely write those 3 down.
Okay.